In this recording, we're going to just walk you through how to use DeltaMath to graph exponential functions. So we have a basic exponential function here, 2 to the x, and it requires that we plot the asymptote and then use these 2 yellow points with whole number coordinates, and these points will sort of snap into place as you get close to the grid lines. We have to have a sense of what this function will look like, so let's go over to some scratch paper and just identify a few points. Alright, so our function is 2 to the x, and we're going to think about using these 3 x values, -1, 0, and 1. In DeltaMath, you only need to graph 2 points, so these are probably going to be the best points. First, we got to get our y-intercept. So that's when we substitute in 0. So 2 to the 0, anything to the 0 is 1, right? So we got that point. Another easy point would be raising 2 to the 1 power, so that would just be 2. So we can see that it's exponential growth already, right? And if we do 2 to the -1, that actually puts the 2 in the denominator. That gets us a half. Okay, so we can see it's growing. In terms of the points I want to plot these whole number coordinates. So I want to plot 0, 1, and 1, 2. And I also can tell that there's going to be a horizontal asymptote along the x-axis. Okay, so I'm going to change this to horizontal asymptote. And now it shows decay here, right? But I'm going to move this point there, right? So we said it was going to be 0, 1, and 1, 2. And we also need to move this asymptote. Should be right on the x-axis unless there's some sort of a shift, a addition on the end here. So I'm going to hit submit, and it gives me some feedback. All right, let's do 2 more that are slightly more complicated so you get a sense of how to do it. Okay, so we kind of went from 0 to 60 here. We've got a pretty complicated exponential function with some transformations, but keep in mind, we just, in our video that I gave you, we talked about the effects of different transformations, right? You guys know from previous experience, what happens to a parabola when you put a negative in front of it, when you negate the parabola? What happens to a parabola when you add 1 on the end? What happens inside the function when you subtract 5? You know all those 3 transformations. So if we can just graph our parent function, which we definitely can, we just did that with 2 to the x, we can make these adjustments. So let's kind of talk this through a little bit. All right, so on your scratch paper, make a little two-way table for the parent function, g of x equals 3 to the x. So let's just discuss what's going to happen there. Let's start with 0. That's the easiest number to substitute in. So 3 to the 0, anything to the 0 is 1, right? 1, 3 to the 1 is 3. And then when we have a negative exponent, we have a whole number base to a negative exponent that gives us a fraction, so we got 1 over 3. We're not going to graph the 1 over 3. That doesn't work too well in DeltaMath, so let's graph the whole numbers, 0, 1, and 1, 3. But let's also make note of our 3 transformations. We're going to deal with the negative here, the multiplication, so that's a reflect in the x-axis. Then we have a shift up, and then we have a shift right, 5 units. Okay, so we have our 3 transformations we're going to keep in mind after we plot the points 0, 1, and 1, 3. Okay, so we've got the point 0, 1 all set. We need the point 1, 3. Got it. Got to state our asymptote. It's going to be vertical. I'm sorry, it's going to be horizontal. Let's move that back up to the x-axis where it will normally be unless we have a shift, which we do. But keep in mind, we're not going to deal with that shift until we deal with this reflection. Just like order of operations, our PEMDAS tells us we have to multiply before we add. We got to deal with this reflection before we can deal with this shift. So let's deal with the reflection. That means any point gets reflected the same amount over the x-axis. So down 3 on the other side of the x-axis, and this point is down 1 to the other side of the x-axis. Okay, so it's been reflected. Now we shift up 1. The asymptote goes first, and then each point goes up 1. And then we shift to the right 5. Okay, then we check our work. It says, yep. In fact, there were 3 points we could have plotted. We could have graphed on our graphing calculator and plotted these points, but hey, we're much better than that, right? We talked about transformations. We have some knowledge. All right. All right, so let's finish off with what will we do if we have a fractional base. Okay, so let's go back to our scratch paper. Again, we've got our 3 sort of starting points here. Don't have any transformations here, so this is kind of a parent function of itself. So again, I'll sub in 0 for x, that gives me a 1. I'll sub in 1 for x, that gives me the base itself, so I have a 1/4. I don't really want to graph that point. Can't do it in DeltaMath, in fact. And when I substitute -1 in, a fractional base raised to a negative exponent actually becomes its reciprocal, right? So that gives us 4. So that's the pair of points I want to plot. -1, 4, and 0, 1. So that actually means it's decaying, right? So back over here, 0, 1 we already have, and we want to go to -1, 4. So we see decay, create our horizontal asymptote, move it up to the x-axis. And there we have our exponential decay function. Okay, and obviously if it got more complicated, if there were other transformations, then you would want to obey them. Thanks for watching.